Hi everyone, welcome to my YouTube channel. I hope you all are doing well. So today in this video we are going to solve Leetcode daily challenge, right? So this is the problem of the Leetcode daily challenge. The problem is N-ary tree label order traversal. The problem is easy only, right? If you know about label order traversal for binary tree. So in a similar way we have to do it, but this time we are having N-ary tree, right? So binary tree have at most two children. Now for N-ary tree, it can have at most n children, right? So given an N-ary tree, return the label order traversal of its nodes values. N-ary tree input serialization is represented in their label order traversal. Each group of children is separated by the null value. See examples. So the first example that we do have for this one, right? So if you are traversing this N-ary tree level by level, so what should be the output? So on the level 0 we have 1. Okay, for level 1 we have 3 2 4. For level 2 we have 5 6, or you can say for level 1 we have 1, right? And for level 2 we have 3 2 4, and level 3 we have 5 6. Okay, and that's what we are having in the output, right? And if you will go through this example, right, so here for level 1 we have 1, for level 2 we have 2 3 4 5, for level 3 we have 6 7 8 9 10, right? So 1 2 3. For level 4 we have 11 12 13. For level 5 we have 40. So level 1, level 2, level 3, level 4, level 5, right? So that's what we are having in the output. The height of the N-ary tree is less than or equal to 1000. That's what the constant even they have given, right? So now for level order traversal, what we'll be doing is the similar way it is going to be like we do for binary tree. So we'll be taking a queue, right? And in that queue, first of all, we are going to insert the given root node, right? So we are going to insert that root node, and then what we're going to do is we are going to explore the other level. So root node, you know, that is 1 is the root node, and that is at the top. This is the level 1. Now we are going to explore the children of the root node. So right, so for 1, if you will see what are the children, 3 2 4, right? And then so 3 2 4 you took inside your queue. Now we'll be exploring for 3. So 3, what are the children? 5 6. For 2 there is no children, for 4 there is no children, right? So that's what we're gonna do is, and simply we're gonna insert this level by level when we'll be traversing. So we'll be insert this value to the array list, right? So that's what it is. Like, I think the problem is self-explanatory itself. Once you'll be having a look on the code, you'll be able to understand that what actually I'm talking about. So let's have a look. So here we have to return list of list, right? So that's what we are taking here. So res to which we'll be storing the value. So first thing that you have to check that if the root value itself is null, then we'll be simply returning this res, right? No need to proceed further. Otherwise, what we're going to do is we are going to take a queue, right, and in which we'll be inserting our nodes. So first we are inserting our root node. Right now we are having a while loop, and we'll be continuing till the time queue is not empty. Once queue is empty, so no need to proceed further, right? So it doesn't make sense. So for each level we have to do the traversal, level order traversal we have. So in this end we are going to store the size of the queue. Size will be depending on the number of elements that it does have. So for now, let's say we inserted root node 1, right? So there's just one element, right? So n value is going to be 1. Now this list, right, so that will be responsible for holding the elements of a specific level. So as of now we are talking about level 1. So now we are having this for loop. It will run till the time I value is less than that of n I plus plus. Now we are popping the current node that we are having. So let's say we are having the node 1. So current is holding the value, right? And now what we're going to do is we are going to explore the children of that particular node that was there in our queue, right? So let's say we were having at the top, we were having 1. Then as of now I'm writing like this, and then for this 1, what are the children? 2 3 4. It has 3 children, 2 3 4, right? So what we are going to see here, this N-ary tree has, see, value as well as list of node of children, right? So what we're going to do is we are going to explore its children now. So for node well current dot children, so we're going to explore all the children of that particular current node. So current node is what? 1. So what are the children of current node? 2 3 4, right? So what we're going to do is we are going to insert them into this queue, right? So first our queue was having that 1, then we removed that that particular node, right? We did here, right? Q dot poll, right? So now we have inserted 2 3 4, right? So in our queue we are having this 2 3 4. Okay, and also this level dot add, right? So in our list that we are having, right? So in our list levels we have added this 1. Okay, because on level 1 we are having just one element. Okay, then what we're gonna do is, again we are going to check this. So queue is empty? No, right? It is having 3 nodes. Okay, 3 elements it is having. What is the size of the queue this time? That is 3. Okay, so for int I equal to 0, I less than 3, I plus plus. So first it is going to q dot poll we're gonna do. So current node is 2, it will be popped out, right? And then we are going to explore the children of 2. So let's say for 2 the children are 6 7. Okay, so this has been removed from the queue now. This 2 has been removed from the queue now. Let me remove it, and it is having children 6 7. So right, so that will be inserting in our queue, right? So our queue is having elements 3 4 6 7, right? Okay, so now I value will be 1 this time. 1 less than 3, the condition is still true, right? So this 3 will be popped out, right? This 3 will be popped out this time. And see, we are continuously adding these values to our level as well, right? So first we added in our level to current dot well, right? So we are adding this. Then 3 also we added in our level. For 3, let's say there is no children, right? So there is no children for 3. Okay, then I value will be what? 2. 2 less than 3, condition is still true, right? So we'll be popping out this 4 also, because you can see 2 3 4 were there on the same label and they were the children of node 1, right? So for node 4 also, let's say there are no children, so we are not going to proceed in this loop, and we're going to add this current dot well, that is nothing but 4 to the level, right? So now we are remaining, let's say we are remaining with just these two nodes only. So this is how we're going to add them as well. So let's say they are on level 3, so we'll be having 6 6 7. Okay, we'll be having, let me write here, 6 7, right? And so and here you can see we are adding this also, right? We are adding this level to our res. So first this level, when our node was what, 1, so it got added, right? And then when the level was 2, where the elements were 2 3 4, it got added. And then for level 3 the nodes were 6 7, right? It got added, right? So we're gonna return this res, and that's what we have to do, right? So it was, you can see this was the similar to that one only that we did for binary tree. Just the thing was that there we were having this left and right child, and that's how we were exploring, right? So I have provided the code in the description in case you want to refer it, but I believe that most of you will be able to code it by yourself. So code it by yourself and just check your answer whether you are able to solve or not. So that's all from my side. Thank you so much for watching, everyone. Bye bye.